Hi there, how's it going?
Hello. Pretty good. How about yourself?
Good. Stateless purpose, that's a pretty good handle. Did you have to click a lot of time or did you get that the first time?
I just got the notification at the bottom right, and then it said join, and it was good to go.
Oh no, I mean the name of your handle. I was just wondering
Oh,
if you selected that or if that was your default one because it's a pretty
I,
good one.
I just clicked a bunch of times. I used to have a different one before, but that was a bit cooler. But I thought I should change it up.
That's funny. Great. Well, I guess we got to pick a programming language. What do you prefer?
Sure. I'll probably be programming in Python, so I'll just switch that over.
Great. Okay. So just to warm up and make sure the audio is working and everything else is in good shape, can you just write a function that reverses a string, without using, a library method like reverse or whatever? You can just pass it that
Sure.
hello world that's there in the.
Right. So I guess normally for reversing in Python, I could pretty much do this to reverse it, but you're saying that I shouldn't be using something like that. So instead, I imagine I'd want to just keep a pointer, right, going from both the ends, and I should just be able to swap the values. So I keep a left pointer starting at 0 and a right pointer starting at the end of the string, and I just swap values until I no longer have the condition of left being less than or equal to right, or less than, really. So left comma right equals 0 comma 1 of s minus 1. And then while left is less than right, we can just swap the values. Then increment left, decrement right, and well, I can't really do this because it's Python and the strings are immutable, so really I'd have to convert it into a list first, and then I'd have to join the result back again. And I think this should be okay for reversing.
Okay.
Just because both the even and odd case should be covered by the left less than or equal to right. Because when they're equal, for odd, it's fine, and then for when it's even, you'll have the final loop, like say it's 1, 2, 3, 4. You'll just have it like the 2 and 3 swap, and then now the condition fails. Yeah. Should I test this one out, or?
Yeah, let's try it out.
Sure. So let's go ahead and reverse. I kind of reasoned through it before on how it'll work. For the actual cases, the main thing we care about is that we cover even and odd, and I guess the empty string. Before actually running the code, I think we should just manually reason through it. So the empty string, you'll have left is equal to 0, right is going to end up equaling -1, so the condition fails. So we just join with an empty string, and that's a-okay. With ABC, you'll have left is 0, right is 0, 1, 2. So first time through, left is less than right, so we swap the values. So now we should have C and A, and now we set left is equal to 1 and right is equal to 1. The condition kicks out, so we just return now this new string CBA, which is correct for reversing. Yeah, and I think we reasoned about the odd case as well. So is it okay if I run this?
Yep.
Cool. Stir object is not. Didn't I just convert? Oh, whoopsies. Okay, typo here is that I'm supposed to set it to s equals list of s, because the actual strings are immutable, so I can't modify this. Can only join on an iterable. A list isn't. Okay, that was a typo. It's supposed to be s, not a list. Cool. So these reverse. Okay.
Good. Great. And yeah, I mean, I hear you. I think if you, doing this kind of thing in Python it feels a little bit contrived, but good job. Okay. So you ready for the for kind of the real question?
Sure.
What we want to do is we want to write a function which accepts an array of integers that can be positive and negative. I'll just type out an example here. And we want to return the largest number that is obtainable by multiplying any three distinctly indexed members of the array together. So if you have some array like this, the right answer happens to be 7 times 10 times 5, which is 350.
Right.
You don't have to worry about integer overflow for the purposes of this, so just pretend that you can have some multiplies which don't cause integer overflow problems. It turns out that there's a variety of ways of solving this problem in terms of how optimal it is. So we can try to work through it together.
Okay, sure. So just before I get out ideas, I wanted to make sure that I have the assumptions on this correct. So looking at your example, I can see that it ends up being both positive and negative values, right? So that's one thing, instead of it just being all positive values. What I'm actually trying to solve is that what I'm getting is that I'm just trying to pick the three numbers in this array such that I will get the maximum product. I don't really care about the order or anything like that, right?
Order of what? I'm sorry.
Order of the elements picked. So it doesn't seem like the values have to be beside each other. They're just any values within the array.
Oh yeah. Sorry, yeah. Any three distinctly indexed, and you're allowed to use, if there are multiple copies of a value in the array, you can use them multiple times. You just can't, in like this example, you can't use 10 and reuse that, and just cube it, right? You have to use the distinct offsets.
Right. So because you say that I can end up doing something like this, but there's positive and negative as well. What I would have initially thought, if it was all positive, is that I could just sort the array and pick the three final values. But because it also includes negative values, it may end up being the case that I have, let's say, two very, very negative values. Like let's say I have negative 1,000, followed by negative 1,000, and then I have 1, 2, and 10. Right? So obviously my solution wouldn't be 1, 2, and 10. It'd be the 2, negative 1,000, and the 10. Which is significantly bigger. So I think what would be helpful is if I tried to keep track of what the if I went without actually sorting. One thing I can do is I can keep track of the three largest items and the three smallest items, and then at the end, using that combination, I should just be able to pick the max between them. That ends up being a linear time solution, just in the sense that if I end up using a heap in order to find the three largest and the three smallest, the heap is size 3, which is a constant. So that would probably work out, but is it necessary to keep track of all three smallest and all three largest is what I guess I'd want to find out. So let's run through this case, I guess. How would I figure out that 7, 10, and 5 are the biggest? So if I were to only look at positive values, right, I would just pick the three largest, right? Let's modify this case a bit. Let's say it's negative 20, negative 10. Wait, let me copy that below. Here my selection should end up being negative 10 times negative 20 times 10. Instead of keeping track of just the numbers, is it easier to just keep track of the products? I'm going to say that actually just keeping track of all three lowest, and I guess it's not all three lowest you need, it's the two lowest that you need, right? and that's the only difference, because now your comparison is just between the two lowest times the highest, or it's the three highest, and those are your only two possible solutions. So if you go with that, we use a heap. We should be good to go for finding the solution in linear time. Is it okay if I go ahead and code that out?
Yep, code wins. So code is always a good thing. Very much on the right track.
I can write the note on that. And is the array. The only one problem with this is I know that Python by default has, say, like a min-heap. There's an undocumented max-heap, but I don't know if it actually works out correctly. Let me, I'll try to use it. Or underscore heapify max, and then underscore heapify. I think those are the right imports for the undocumented functions, but let's go with that. So the normal heap is just a min-heap. So let's say that let's see, how are we actually going to go and iterate through? Should we just take the first two values and start from index 2? Yeah, every time that you're going through, you're just going to check if the value that you have is going to be lower than the root of your max heap to find the lowest. Because if it's smaller than the largest there, then that means that it's one of the two smallest. And then you have the opposite for the highest values. You're going to have a min heap, and then the root is going to be the smallest value. Should you? I don't think I considered what happens if an item is both in the min heap and the max heap, because it seems like that kind of messes up my calculation. Because if I were to say is it possible for something to be both within the smallest and the largest? I think so.
Sure, if you have three elements, that's a good example.
Yeah.
That could happen.
But does it make a difference? It would, because in that case, the calculation that you might have is going to double count a single element. Actually, no, that's impossible. I don't think you can double count, even with three elements, because your largest is going to be, the largest in your largest set, and then the two items that you're going to find inside of your smallest are going to be the one that isn't the largest. So there's no overlap or double counting that's going to happen. So in that case, it's totally fine, I think, to just append whatever we want to these heaps. Right, so it's heapify max heap, and then highest. Just add 2 instead of 3. Start off, just so that when we loop through the items, we can start off at index 3 or index 2. Right, so repeating again, we have the lowest calculation that says if our value is going to equal array end. We have if our value is lower than the largest value we have inside of our lowest heap, and we just want to replace the value. So heap push underscore heap push pop max on lowest with the new value, and if the value is greater than the highest at 0, then we just heap push pop on highest with the value. So just summarizing that, we're just iterating through the entire array, and we're just replacing heap values as they meet the conditions. And what we said we'd end up having is that you either have the two lowest you'd either have the two lowest or the three highest. The two lowest multiplied by the highest, or you'd have the three highest multiplied together. So what is the best way to do that? For the highest, it's it's a pretty easy product to figure out. It's just highest of 0 times highest of 1 times highest of 3 2. The alternative, there's a small bug with the highest portion that I can update after. The two lowest end up being just lowest of 1 and I guess lowest of 2 times highest of this is a min-heap, so highest of 2. Did I get that in the correct order? So the bug with highest, it's supposed to be 3 elements instead of 2.
Yeah. Also, I'm not sure how do you get lowest 1 and lowest 2 given that you have 2 elements in lowest?
Oh, right. Yeah. These are supposed to be just the 2 lowest that I have. So it's just highest that I need to look at. This one is supposed to be 2. I think I'm not actually, that's not guaranteed actually. I need to actually do it by the max of highest. Because the only property I have of highest is that the lowest value in it is going to be at the root, and then there's no guarantees on what index 0 and index 1 are going to be because it's a heap. Yeah, so I think that does end up being the translation of what I talked about, but it's probably helpful to go through a case just to make sure that the code is actually correct.
Yeah.
So let's go through the test case that I had above, where this is a pretty good example, just because it's shorter than the one with the -20 and -10. So we start off, we say that we have a max heap of the first 2 values. And so in that case, we are going to have, we're going to say that the 2 largest values we found here are -1000. Oh, this is supposed to be non-unique? No, non-unique. So -1000 and -1000. Our highest at this point is -1000, -1001. But this is a min-heap, so the -1000 is actually at the root. Cool. So now we're at index 2. What we end up doing here, this is a bug, because what we're saying we want to do at this point is if the if the value is greater than the highest at this point, we are going to heap push pop. So the error that'll come up here is that we'll have 1, 1, and -1000 here, which is not correct. This ends up just being a small off by 1 based on the fact that like the lowest heap starts at a different index than the highest one. The simplest way to fix this is we could just say that if ind is equal to 2, then we skip this. right? So we say if int is equal to 2, we just skip this check. I wanted to continue with the other checks, and maybe later we could find an alternative way to do this, but this should fix the bug.
Mm-hmm.
The other branch was just that, yeah, if our value is lower than lowest, we would push, but that fails because our value is not less than negative 1,000. So cool, we go to the next index. Again, our value is not less than lowest, so that branch fails. Now, because we're index 3, we'll actually get this check of if value is greater than highest. It is, because again, highest is a min-heap. So our value of negative 1,000 is going to be pushed off, and the value of 2 is going to replace it. So now we'll have negative 1,000, 1, and 2. Negative 1,000 is the root. Cool. We go to the next index. Now we find the 10. So again, this fails the lowest check, but this 1,000 gets replaced with 10. And now we're done iterating through. We check, we multiply together the 3 values of highest. That only gives us 20. And the alternative is negative 1,000 times negative 1,000 times 10, which is going to be the max product. The positive case, I want to say, is a lot simpler, so I think this should be okay overall for test cases. The only other check is invalid cases, and we have our if at the top to just, return if length of the array is less than 3, then it's definitely 0.
Mm-hmm.
So
it all seems very believable.
Yeah. I think that would be my final solution.
So I'm not as familiar with sort of heapq in Python and the sort of heapify stuff. Is that syntax there? Is that going to keep it a certain size, or how do you?
Oh yeah. So all we're doing when we say heapify, we're just making a heap using the first 3 elements. And then heappushpop, what it's going to do is for that heap, it's going to push this value into the heap, maintaining the heap property, and then it's going to push or pop, meaning that the the highest value, or because we have it as a min heap, the lowest value would be removed.
Okay, so that keeps it a certain size. But don't you need to pass the actual array somewhere on line 28 to 29, or am I just not counting?
What do you mean, past the actual array? Oh, I see. Okay, yeah. This is supposed to be array, and this is this is a typo.
Okay. I thought I was just like, but how does it know to make it out of the array? Okay, cool.
Yeah.
Great. Should we try it?
Sure. Yeah, with actual code. Cannot import name. Ah, dang. Okay, this might be a Python 2 only thing. Let me switch over. It just erased everything. But good thing I copy and pasted. Okay, cool. This exists in Python 2. It does not exist in Python 3.
Okay.
Let's run highest product on negative 1,000, negative 1,000, 1, 2, 10. None type has no.
No, it doesn't want to give them to you with an index.
Yeah.
But also, lowest is what? Huh.
Let me just check again with the actual API from heapq, import heapify max. Say of array, right? Oh, right. Okay, I mixed this up. So it actually ends up being that I need to create lowest like so. highest as being the first three elements, and heapify max and heapify, those are in-place operations.
Oh, they don't return anything. That's hence the none.
So that's why, yeah, it was returning none before. Now that error should not be here. Global name heappushpop is not. I think maybe it's heap push replace, or is it okay if I check up what the actual API is called?
Yeah, probably a good idea.
Function. Okay.
It's in Python 3. It looks like it's heappushpop.
Yeah. There's heap push, there is a heappushpop here as well, according to the docs. Okay, it should be able to use heap place if anything. Oh, it's because I put an underscore. That's never mind. Cool. And I think that is the correct answer of 1,000 times 1,000 times 10.
Okay.
1, 2, 3. Yeah, I'll assume that's correct.
Okay. Of course, you gave it a sorted array, so we should try some other cases which are a little bit.
Not the same. Okay. We could probably use the same values, except just reorder them. So say that it's here, here. 1 is at the beginning. Missing a comma somewhere, right? No. Cool. And instead I get 20. Interesting. Okay. That means that I probably have an error with how I handled lowest. Or I'm pretty sure I don't have the, the heap types reversed. Just because heapify should be a min-heap. Oh, I see the typo. Again, instead of me putting heapify max on lowest, I just did it on the array itself.
Mm-hmm.
Okay, cool. And that gave out exactly what we would want. So the logic is I think still there. An example with only positive cases. Just get rid of the 1,000. And again, we got 2 times 10 times 100, which is correct.
All right, let's try some all negatives and some zeros.
Some negatives and some zeros. Oh, okay. I did not think about what would happen if you have zeros in here. So, and a very simple counterexample that would fail on this, or is it a counterexample? I was thinking for a second you could have negative 1,000, negative 1,000, and 0, but then the max product in that is actually 0. If you had negative 1,000, negative, you can use smaller numbers, negative 5, negative 10, 0, negative 3. I want to say that this will pick 0. Yeah, which is actually correct in this case. Mm-hmm. But if you add more positive values, or add more negative values rather, it should ultimately pick you some positive sum, but it won't. This answer does not account for when you actually have 3 negative values. So yeah, I give 0, which is, what am I saying?
Correct.
That is true. It is still 0, yeah.
Try adding a one positive number in there.
Sure. So let's say I add 2.
That should be 100. Yep.
Right.
Okay, so that's working well. Try all negative. And don't sort.
Right. Sort. So it's negative 3, negative 5, negative 1, negative 2, which is negative 6. That is correct.
Yep. That's as good as it gets. Let me try my favorite example to start with.
Okay, so this should be the 5.
Oh, apparently I don't know how to type. That's unfortunate.
Def revis. When did we use that?
No, it's just confused. I just forgot a parentheses. Okay, good. We got our 350. Nice.
Cool, which is 5, 7, 10. Yeah.
So what do you think the kind of the big O efficiency of this is? I know you kind of talked about it as you're working through the problem, but let's chat about that for a bit.
So I said earlier that it ended up being big O of n runtime, or n is the length of the array. Normally, when you're performing this operation, you could think of it as like big O of n log k, just because the heap operation's all taking, logarithmic time. But because we know that the size of the heap is always going to be 3, that's a constant. And because of that, it's also constant space complexity.
Right. Yeah, which is great. Do you think you can do better than O of n?
Better than O of n. Immediately, what I would think of is if it was a sorted array, but I can't make that assumption, right?
Right.
So better than O of n. I want to say no, because at minimum, I have to go through every single element in the array. So that is a lower bound on completing this problem.
Yep, that's exactly right, which is very important to know, because that way you know when you can stop optimizing, right? Like how good can it get? And so unless you know something about the array, like, oh, it's already sorted, or you know something about the values of the array, you basically have to look at every element, which fundamentally makes it, an O(n) exercise. Great. Any other kind of questions or comments on this problem?
No, I think this part here makes sense to me.
Yeah. What did you think of it?
It was pretty good. It wasn't. It's really similar, I want to say, to a lot of heap problems, but that's only once you recognize it as a heap problem. Initially, when you look at it, I don't think you would think they would use a heap. So, it was different than like normal heap problems, where it's like, oh, it's so obvious because they ask you for like the k closest neighbors or something like that, right?
Yeah, and I think it's one of those, I think one can think of it as a heap, and sometimes people do it without a heap and instead do it with, kind of just do it with variables. I had somebody show that to me, where instead of using an array or a heap or any other data structure, they simply defined max1, max2, max3, and min1 and min2, and then just kind of moved them around. And amazingly, that actually is almost as compact as the code that you wrote here, and pretty easy to follow, as opposed to having an array or something more advanced. Then you have to deal with library functions. But it all, of course, ends up the same thing, which is basically you have a fixed size min-heap and max-heap, and you walk through the array once, and then you do your multiplication tests.
Right. Yeah. The actual pure numbers thing is what I would have guessed, but it seems complicated to write out, I guess.
Yeah, that's right. Cool. Anyway, very good job on this. You were very fast. That's great.